So my question was this 3a log y plus 1 plus x, right?
Hmm.
And I had to, I mean, prove it concave, convex. Up till this thing, it's done, right?
Yes. Yes.
So we have to do,
We individually proved objective function as concave and constraints convex. And for what values of a greater than zero is this later condition satisfied? That we did.
okay. So let's find out for the conductor, what is the optimization problem? So first of all, what we did, it's all messed up. There's the function here. So we wrote this function.
Hmm.
We took x and y and three multipliers. Why three? Because of three
Three
constraints.
constraints.
And it was not like k minus gx always. You
Yeah, we
have
need
to
a
take
positive
care of,
lambda.
yes. You have to take care of because the constraint for KKT is greater than or equal to 0. So
Zero.
equal
Yeah.
to 0 comes in complementary slackness and greater than comes here. So we have this function and then lambda 1,
Ma'am, one
lambda
second, ma'am.
2.
Equal
Huh.
to or greater than zero constraint is when we have complementary slackness.
So
Yes.
we only can have the condition for Lagrange multipliers here. So in Lagrange multiplier, when we apply Lagrange theorem, we can have lambda
Hmm.
positive, negative, 0, anything. But here
Yes,
we
yes.
can have only greater than or equal to 0.
Only greater than or equal to zero. Got
So
it. Yes, ma'am. Multipliers are greater than or equal to zero.
this is the condition when I'm writing the function. This is the condition when I'm considering maximizing, like greater than 0, right?
Yeah.
And here, when I'm substituting these lambdas equal to 0, this is when I'm considering equal to 0 actually.
Hmm. Right, ma'am.
The consecutive lambdas value, I'm
The
putting
constraint.
it 0.
Yes.
So this is
Equal
called
to
as
zero.
complementary slackness, okay?
मैम उसका मतलब क्या है? Why do we call it
Slack,
ऐसे? Do we
what do you think? What is slack?
slack
Slack is strict.
inequality? We
Hmm.
know
Huh.
slack
What
and
is it?
strict inequality. Oh, we
Slack
equal
is
slack
equal.
includes equality. Strict is
Yes. So what we are, what
100%
we
inequality.
are, so for equality, we are considering the slackness by putting all these lambda value as 0. You can see that ultimately there is no point of having these multiplier as 0. Actually, you are getting lambda 1, lambda 2, and lambda 3 0 only by keeping the whole expression as 0, right?
Yeah, after the first derivative.
Not really. If I'm substituting all these values, so do you know that if I have x minus 2, x minus 3 as factors and I'm substituting 0, so x minus 2 is also
X
0,
is
x minus 3 is 0.
0, x minus 3 is
So
also 0.
lambda 1 is
Yes,
0,
ma'am.
1 minus y minus ax is 0. We are just putting that, keeping these constraints in mind,
Oh,
we are having the slack that is equal to 0. Fine.
hmm.
Now,
Yes, ma'am. Got it.
so this is the difference, major difference between KKT and Lagrange. Okay, once you are done by writing all of them, like firstly the function in Lagrange form, then you take the derivative of x and y equal to 0.
So we are finding, ma'am, we're technically finding the maximum point since it's a concave function. We are finding the maximum point of the function where x equal to 0 and y equals to 0.
Yeah, I mean, those constraints are applied, and I want to find out what are the values for x and y,
Subject to a constraint.
subject to constraint.
Hmm.
So for that, I'm substituting these as 0. First of all, the
Hmm.
question has only asked me what is the condition for KKT if you want to apply KKT. So firstly, you'll write this has to be the function. Then you will say the first condition is stationarity, wherein you will write that the function with respect to x and y has to be 0. Then you have dual feasibility, wherein you will
Ma'am, one second,
substitute.
ma'am. I'll write this down. Check. Okay. Just, okay. Yes.
Then you have dual feasibility. That means two possibilities, equal to and more than 0. So greater and equal. Two things are there for your lambdas.
Okay, ma'am. Why do we are equal to 0? Got it.
Greater than or
Uh,
positive. It can be positive. It can be 0. Only two conditions are there.
multipliers can be positive or 0. Got it.
So that's why we are writing. Just a condition we are writing because question has asked me. For what values of A can you solve the optimization problem using the Kuhn-Tucker? The value of A and write down the Tucker's conditions. What are the conditions which have to be there if you want to solve this for maximizing? Okay. Can you see the question? I mean, are you getting the question?
Yes, yes, ma'am.
So I'm in the process of finding A, finding X and Y, and then finding the maximum of 3A log Y plus 1 plus X. Okay.
One second. Can you repeat the last sentence, ma'am?
Huh. I'm in the process of finding the value of A for which Kuhn-Tucker has to be applied. Then I need to write all the conditions of Kuhn-Tucker, stationarity, complementary slackness, and everything. Then I need to find out the solution, like maximization of function, where it will be maximized. Okay,
Okay.
the final answer of this function. And
Samjha.
the question is actually up to this part only. Then this is another thing wherein we have to use another theorem, which is
Envelope
envelope
theorem.
theorem. Okay. So I'm covering A, B, C together. So firstly, I have jotted down all of the conditions which are this stationarity, dual feasibility,
Dual feasibility.
primal feasibility, that is the constraint,
If the
and
constraints
complementary
hold.
statements.
Yeah.
Now I need to find out the value of A. So I'm considering all those conditions. Conditions are, let's go back. Could you please jot down the conditions so that you can tell me what are they? These are.
Yeah, just one second.
Hmm.
Yes, ma'am.
Okay. So, oh, these are three conditions, right?
Yeah, y plus ax is less than or equal to 1, where y is greater than 0 and x is greater than or equal to a. Y is
Okay.
greater than or equal to 0. Please.
Greater than or equal to 0, and A also needs to be greater than 0, right?
A is greater than 0.
Okay. So now I need to find out the value of A, possible value, wherein all these constraints will be there. And yeah.
Ma'am, now we need to find the possible value of a where all these constraints are met, right?
Yes.
We did that for your Slater condition also.
For Slater, we did not use equals. Now I need to use equals and find out with the actual constraint. Okay.
Okay.
So I have taken first one, y plus ax is less than or equal to 1. Now I need to substitute y and x something, then only I'll be able to find out a.
Yes.
So because y is greater than or equal to 0, can I assume one of the points as y 0? Because it
Yeah.
is equal to sign also. So I have
Yes.
substituted y as 0. So ax is less than or equal to 1.
Yes.
Y is gone. So x has become lesser than or equal to 1y,
Listen.
right?
Yes.
And one relation between x and a is already given. X is greater than a. So that means x belongs to a and 1 by a, right?
Hmm.
If bigger value is 1 by a, that means a tends to almost 0. Like a is very small, right? Because it's reciprocal when it, for example, if I'm saying zero point 0.2,
Yes, yes.
yeah,
Yes,
zero
ma'am.
point 0.2 is 2 by
Since
10,
it's
so 10
greater.
by 2. Huh.
Hmm.
So A is supposed to be very, very small if it it wants to lie in the physical region. So I have found what? I have found X at the moment. I need to find A, right?
Okay.
Huh. Now, what is there? From this feasibility, I can say A is smaller, 1 by A is greater, right?
Yeah.
So A I found out, right? You can take this A here, A square is less than or equal to 1, A is less than or equal to 1, right? Hello?
Yeah. Oh,
My main aim is to find out A for KKT,
less than or equal to 1. Okay.
because A from this relation I can say A is lesser than 1 by A. So I need to find out A. I have taken A into A, that is A square less than or equal to 1. So A has become lesser than or equal to 1, right? I'm
Yeah.
not taking minus 1 because A has to be positive.
Hmm.
Now I have found out A also, X, and now it turns to find out Y, right?
Yeah. So
So
y
Y is
plus
greater
x
than or
plus
equal to 0.
y is greater than or equal to 0.
This
Yes,
is the
ma'am.
condition. And y plus ax is less than or equal to 1. So what is y
Hmm.
from here? Y is less than 1 minus ax, right?
Yeah. You
So
take ax.
I have found the range of y. 0 to 1 minus 0 is the lesser, and 1 minus
Hmm.
ax. Y is lesser than
Right.
1 minus ax. What has happened here? Y is greater than or equal to 0. What has happened? Y is greater
You
than or
have a
equal to
range
0,
for y.
and y is lesser than or equal to 1 minus ax, right?
Yes, ma'am.
Lesser than. So this is the range for y. Is this fine?
Yeah.
What does it mean? That 1 minus ax is way greater than 0.
Mhm.
1 minus ax is greater than 0.
How, ma'am?
See the sign. If I
Yeah,
have
but then
written
if
that
it is
2,
greater than or equal to y, and y could also be greater than or equal to 0.
so see, if I have written something like this, so that means what? Oh, this has to be 3
It's
into.
3, the 2.
Huh,
Ma'am, but then,
huh. Of course, you will see that the equal sign is not applying here. So I have to come up with some values wherein it is equal. So if you
yeah,
forget about equal, because equal,
yeah,
if I take equal, then it is ultimately this only. But if I have to take other values than the equality, then of course you will say that 1 minus ax has to be greater than 0.
right, ma'am.
So this is one such value. Either these two will be equal, 1 minus ax will be 0 only, or greater. Is this fine?
हाँ. Ma'am, but then again, मुझे ये I'm finding it difficult to understand कि मतलब how.
Okay.
Oh, why? Yeah,
Uh,
yes, ma'am. 1 minus x is less greater than or equal to 0. That is yes, that is fine.
so that means I can, I mean, I have found out some values wherein y is greater than 0, 1 minus ax is also greater than 0. So somewhat I have considered that y is equals to 1 minus ax. At the moment, by a part, I was supposed to find out the value of a, which I have found out, right? Now it's time to
Hmm.
find out the optimized value of the function. Okay? The function
Right.
which is maximum xy. What is it? Why it's not going up?
No, it's not responding.
Jot this down. Functions value
Hmm.
maximum xy 3a log y plus 1 plus x. नोट हो गया?
Yes, ma'am. हाँ.
अब इस फंक्शन में y और x की वैल्यू डाल देते हैं जो हमने निकाली। y की
Okay.
वैल्यू क्या निकाली है? 1 प्लस ए एक्स,
रेंज निकाला है 1 + ax.
0 से
ओ
1
नो नो,
प्लस ए एक्स तक,
रेंज के
1
बाद जीरो
माइनस
से.
एक्स।
हम्म.
So what we are doing, my function, tell me what is it? 3a,
3a log of y + 1 + x.
ओके। इसे मान लेते हैं वैल्यू फंक्शन जो मुझे प्रूव करना है।
Okay.
अब मैं वैल्यू रख रही हूँ log y की वैल्यू, अगर मैं रखूंगी y की वैल्यू क्या थी, कंस्टेंट क्या है मेरा, ये 1 माइनस एक्स
1 -
प्लस
x.
1 प्लस एक्स। ओके, तो क्या वैल्यू आई?
Writing it down now. 3a log ax आया. अच्छा नहीं. नहीं मैम. हाँ, 2x. यस, 2 - ax
तो ये
प्लस
मेरा
x.
फंक्शन है,
हाँ.
ये कोई
हाँ.
फंक्शन है एफ एक्स वी एक्स वॉट। अब इसको क्या करेंगे?
हम्म.
डिफरेंशिएट करते हैं टू फाइंड आउट मैक्सिमा, मैक्सिमा मिनिमा, जो भी क्रिटिकल पॉइंट्स निकालने के लिए क्या करेंगे? डिफरेंशिएट।
यस
तो डिफरेंशिएट करो विद रेस्पेक्ट टू एक्स।
मैम, एक क्वेश्चन है. हम लोग इसको सिंपली पार्शियली डिफरेंशिएट क्यों नहीं कर सकते?
पार्शियली करेंगे केवल एक्स के रेस्पेक्ट में, पर एक्स ही है ना पूरा।
हम्म. ठीक है
क्या आया?
मैम. इट्स गोना बी 3a.
हम्म, 3a
1/2 - ax
राइट।
+1.
होल्ड ऑन, चेन रूल लगाना भूल गए।
Oh, sorry. Minus. So into, yeah, into -1.
और माइनस ए, तो
Oh
ये तो
yeah,
कांस्टेंट है, सो
minus
यू आर
a.
कीपिंग।
Yes, yes, constant है -a +1
सो यू गॉट 3a ब्रैकेट माइनस ए
upon 2 -
अपॉन 2 माइनस
ax.
एक्स ब्रैकेट क्लोज प्लस 1, राइट?
-a +1. Yes, ma'am.
Equal 0. You have to substitute it to 0, right?
हाँ.
Now find out the value of x from here. Simplify it in terms of a.
Okay. 3a minus a minus ax minus ax minus 3a square equal to 2 plus x.
क्या आया?
क्वाड्रेटिक इक्वेशन मैम। एक्चुअली इसको बिना क्वाड्रेटिक के भी आई कैन सॉल्व,
मुझे तो ए की वैल्यू थोड़ी ना निकालनी है, एक्स की निकालनी है ना।
मगर इन टर्म्स ऑफ ए करना है ना मैम।
हाँ, तो ये हो गया
ओ,
ना,
इन टर्म्स ऑफ ए तो।
2 -
ओ
3a²।
हाँ, सो यस मैम, गॉट इट।
तो
थ्री
ये
ए
मेरा
स्क्वायर प्लस टू इक्वल्स एक्स। मैम सो इट इज इक्वल टू 2 - 3a the whole square. No, 2 - 3a square upon 2 upon a.
okay. So this is my new x for which the function has to be maximized. I need to find out both of them, maximize for x and y. So y star also I'm supposed to
Minus
find out.
3a square plus 2 upon a equals x. X value आया
X आ गया ना. Now
2
we have to find
minus
out y.
1 second मैम, x का वैल्यू मैंने थोड़ा गड़बड़ किया था. I'm solving it again. So I got 2 minus 3a square upon a is my x value, and y का value I substituted to the equation. इनिशियल वैल्यू इक्वेशन करना है, मैं उसमें सब्स्टिट्यूट करूंगा.
हाँ, y की जो वैल्यू मानकर हमने x निकाला था.
ओ मैम, वन क्वेश्चन मैम.
Yes.
even if we even if we sort of substitute this in the value function that we have taken, same value आएगा क्या?
If you put x and y into the equation in the function.
No. Yeah, but then that is logarithmic function.
हाँ.
log है उसमें, so log एक्सप्रेशन है, तो आई थिंक वो कॉम्प्लिकेट करेगा.
सो जब हम x और y निकाल लेंगे और a की वैल्यू, तो अभी तो हमने मैक्सिमा निकाला एट एक्स एंड वाई. जब फंक्शन निकालेंगे तो इन्हीं एक्स वाई को उसमें रखेंगे. लॉग हमें वी हैव टू कैलकुलेट इट बाय कैलकुलेट. ओके.
1 सेकेंड मैम, मुझे समझ नहीं आया क्या बोले.
ओके, पहले हम वाई स्टार निकालते
ओके,
हैं.
तो 1 - 2 plus 3a whole square, y star. 1 plus 3a square.
Now I'm, because it has the range of a, I need to check it for, you know, there. I have found out that a is also ranging. For example,
A
x
is
was
between, yes
between
मैम.
what, a to 1y, right?
यस, ए तो हम लोग को मिला लेस देन और इक्वल टू 1.
And also the boundaries which are given. You have jotted now. Okay, tell me what are the
यार
boundaries
ए तो
constraints?
ग्रेटर देन जी, नहीं.
First is x greater than a, greater than equal to a.
एक्स ग्रेटर देन ए. यस, एक्स इज ग्रेटर देन इक्वल टू ए, वाई इज greater than or equal to 0,
हाँ. And also if
and
I
x is
split
less than or
this,
equal to 1 upon a.
हाँ. Now let's check for this one first. If x is greater than or equal to a and y is greater than or equal to 0. So this is x, 2 minus 3a square by a. This has to be greater than or equal to a. I have simply
One second,
uh,
one second.
placed the
Yes मैम.
value of
हाँ
x
हाँ.
in constraints. Okay. So that means what is the value for a now? 2 minus 3a square. Tell me what is the a.
A square, ma'am. So it's gonna be 4a square. So 2 is greater than or equal to 4a square.
4a square.
A square is greater than or equal to 1 upon 2. A is less than or equal to 1 upon root 2.
So I found out exact value of a when x is greater than or equal to a. Now when
हाँ.
x is less than or equal to 1 by a, then again the value of x, right?
Yeah.
Tell me if from your
So it's gonna be so ma'am 2 less than or equal to 3a square. So a square is 2 upon 3 less than or equal to 3
uh,
upon 2.
2 minus 3a square. A is
Hmm.
gone. So 3a square
Yeah.
here, but 2 minus 1 is
2
1,
less
no?
than or equal to 3a square. So
इधर 1 ही
2
आएगा.
upon 3.
2 minus 1, 1.
Oh, yes, yes.
Hmm. So A has become now greater than or equal to 1 by root 3,
Greater
right?
than or equal to 1 upon
Negative,
root 3. Yes.
negative value I'm not taking, otherwise quadratic equation has to have two roots, but here A has to be greater than 0, right?
हाँ मैम मगर ओ हाँ ओके.
So I've got
हम्म.
two values. So A is lying between, it was when it was A and it was 1 by A. So 1 by A, 1 by root 2 and 1 by root 3, right?
हम्म.
So I have got the limits and the value of x and y also, right? Value of A, like condition of A for which Kuhn-Tucker can be applied. That we found out earlier. A has to be greater than or equal to 1 sort of something, right? Initially we found out that.
ओ डैम मैम.
Where was
अभी
it?
हम लोग को कंटर का कंडीशंस अप्लीकेबल कहाँ पे वो मिला है.
So no,
No, we haven't optimized it.
up till here, A greater less than or equal to 1. This was part B, wherein if it is the condition when A is less than or equal to 1, then only, and A is greater than 0, which is given by question, then only I can use Kuhn-Tucker. Then I actually use Kuhn-Tucker. I mean, I have tried to find out
We took the
Vx.
value function. We took the differentiation of the value function. We substitute the value of y.
Hmm,
उसके बाद हम लोग ने the value of y substitute करने के बाद we got the values of a
great.
after
Actually,
having substituted the values of x.
yes. So after substituting value of x and putting the limit, the range in which A was lying, we have got the values of A, right?
हाँ.
Now this part is done. We have to come up with envelope theorem. I'll tell you the maximum function. Envelope will also help in finding that out. I found out
ठीक है.
x, y, and A. Envelope is something when, what do you think? Literal meaning of envelope is what?
No, I know the letter वाला envelope.
But if something is enveloped by, what does it mean? It is
Oh,
cap
envelope covered or
covered.
cap. हाँ.
Huh. So this is also the same thing. You have some constraints and you are enveloping them, and you are considering the parameter. Here, what is the extra parameter other than x and y?
एक्स एंड वाई के अलावा मैं भी वन मोर फंक्शन
Which is
और वी हैव
we have a, which is
ए.
extra, right?
हम्म. मैम
So
मगर
here,
ए कंस्ट्रेंट नहीं है ना. ए का रेंज है हमारे पास.
हाँ
ओ
मतलब
यस यस.
पैरामीटर तो है ना.
उस पैरामीटर है. हम्म.
जैसे हम पैरामेट्रिक फॉर्म निकालते हैं इन डिफरेंशिएशन dx by dt और समथिंग लाइक दैट, तो यहाँ पर भी इफ आई टेल यू द मीनिंग ऑफ एनवेलप थ्योरम, then you will see that there is one graph, you will plot it. Let's say you have found out your function was having some variable x
हाँ
plus extra parameter. It is theta, it is a here, anything. Then you will find out the value of x, new x, just like you found out here, and you will put the value of parameter into it. So when you make a graph of this fx, like putting x theta and then putting x theta into the function, you will get the values and you plot the graph. You will see that you will find a point which is actually the maximum of x theta. Why maximum? Because the function is concave and all those constraints have to be convex. So you'll get the maximum value. And here you can envelop it with the differentiation with respect to the parameter. Differentiation of new
वो
function with respect to parameter.
नहीं समझ में आया मैम।
नहीं आया? Okay. Let me, okay. Easy term में बात करते हैं. I'll help you in visualizing it later on. अभी के लिए, what you are supposed to do, envelope theorem states that the function which is given to you, you can find out the rate at which that value is increasing. Increasing, why increasing? Because it is
Because
concave
it's a
function and
convex.
constraints are convex.
Constraints are convex. Yes.
So you will see that optimal value is increasing. But why? I mean, with respect to what? With respect to that extra parameter, which is a here. And how can you find out? You can find this out by substituting the optimal values into the derivative. And that derivative you have to take with respect to the parameter only. Abhi, I'll tell you what does it mean. For example, tell me what was the value function here. After
Ma'am, it
putting,
was 3 log y plus 1 plus 6. After putting the value of y,
okay, so it was, your function was 3a log, if I have to put the optimal values, which I have found out, y star and x star, okay, this is my value function. So what you need to do,
ma'am,
envelope
these are the points. We put y star and x star, and these are the points. These are the optimal points. These are the
yes, where function is maximum.
since it's a concave function in general, we are seeing the we are technically at a global maximum here,
Yes,
and now we are seeing the envelope theorem.
yes. And at that point, I want to find out the slope or, yeah, the slope using that parameter value. I mean, how with respect to A, this optimization changes. This is what I want to find out. And for that, I can use envelope theorem. So it is nothing extra. What you are supposed to do, simply derivate this function. I mean, change the function which is given in the question into the optimal values by substituting the optimal values into the function y star
Okay.
x star. And then you simply derivate it. Like total derivation you are writing, but actually you need to do it the partial derivative with respect to the parameter. With
Oh,
respect to the parameter, because you just want to know, now there is no value of x and y for you. You want to see, you have found out that with respect to x and y, you will get the maximum value. You want to see the change in the function when you are increasing a. So for that,
Hmm.
I need to differentiate with respect to a to see the change or slope with respect to a. Okay. So tell me the
Okay.
differentiation with respect to your.
Ma'am, so it's gonna be 3 plus.
This is in multiplication, no? So 3 log
Yes,
something.
ma'am. So,
This whole is constant.
yeah, so oh, chain rule. 3 into log of y sub plus 1 plus.
This is 0.
मैम मगर यहाँ पे चेन रूल लगेगा ना.
But we are doing only with respect to a. So only this one. Other than that, everything will come out as 0. So chain rule is
Okay.
how? 3
हाँ.
differentiation of 3a
नहीं
you
नहीं,
have
even if
found
you
out
put chain rule, it's going to be 0.
0. Now
Hmm.
you've got the functions value. Okay. What were the, because this is with respect to a, so you need to put values of a. What did we find out? The values of a. The range of a is between
Between 1 upon root 2 to 1 upon root 3. 1 upon root 3, 1 upon root 2. Yes, ma'am.
just if
Greater
you
value is 1
substitute
upon root 2.
if you substitute the value of a, now you will say that, ma'am, there is no a here. How can I find out whether
No,
it
this
is
is our
increasing or
basic
decreasing?
second differentiation.
Uh,
At
I can also do this way that if this is log y star plus 1. So you
yeah.
know what happens with log's value. If I find out 1 by root 3, what is 1 by root 3 if you do calculator? If you use calculator, what is 1 by root 3
So
exactly?
I think 1 upon 7.3. 1 upon 1.73 and 1 divided by 3. It's 0.577. 0.558.
And if you see 0.577, this y star plus 1 is almost what? Tending to 1, right? Because y's value is greater than or equal to 0. If I substitute that, it is almost coming out as log 1, and log 1 tends to 0.
Yeah.
So what is happening? You will see that this is going to increase. Derivative is going to increase. If it is increasing, then you will get the positive slope. If it increases,
Okay.
you will get positive slope. So what I'm supposed to do, I'll put the value in terms of a here in order to get it. 3 log, tell me what is y star value.
Ma'am, so y star value 3 log in 1 upon root 2 case, ma'am.
We found out optimal values. What was y star? X star, y star. What was y star earlier?
Oh, minus 1 plus 3a square uh, plus 1.
Now substitute the value.
Hmm.
Tell me the answer. Log 1 is
एक
0.
second ma'am.
Hmm.
Okay. Hmm.
This you tell me using calculator. Three log 1.5.
Hmm.
कितना?
2, 3. Ma'am, it's 0.53.
Can you see it is increasing if value of A is increasing?
Yeah.
So yeah, envelope theorem states that optimal value increases with respect to the parameter A. This is what envelope theorem states. You have the covered value, the maximum value you found out, but still there is variation. If you keep increasing your A value, the function will keep increasing, okay?
Got it.
You can substitute any, these are exact A values which we have found out. But as we know, A is ranging from this and this. So if you want, you can use any other values also to see what is happening. Like 1 by root 3 is 1 upon 1.7, whatever. 1 by, okay, 0.577. You can use A as 0.6. You can use up till 1 by root 2, you can have various values to prove that slope of value function is increasing by increasing A. Okay.
समझा मैम.
तो
Ma'am,
देखो
and I
मेरे को
did see.
हाँ
Sorry, ma'am. You can cut. Sorry.
no please ask.
Yeah, sorry. While you're explaining this, मैंने थोड़ा debate करके I wanted to see how many other types of questions can I get like this, and all of them are similar ways only. सारा
Absolutely.
practice
हाँ
questions are.
हम्म.
हाँ. And thoda, ma'am, to be honest, last 10-15 minutes envelope theorem was bouncer because Kantakar I can understand majority of it. Visualization of Kantakar is also difficult. But then envelope I'll take 2-3 hours of practice. My
So
Then
let
I'll
me
be able to understand
हाँ,
concept.
of course, self-study is important, but let me again recap for you. It's
Yes,
just
ma'am.
that, it is because they are saying it is another theorem. That's why it seems to us like another thing which we have to remember or learn or do. But actually, it is not. It is the extension of the question. What you are doing, the value of A, which you have found out up till optimal optimization or up till getting optimal values, you simply need to take the function which you have found out up till x star y star.
Hmm.
Hold on. This was my function. This is actually my function, but in terms of x and y. This was actual function. 3a
Yes, ma'am.
log y plus 1 plus x. I have simply put down y star x star because envelope theorem is also about what? Optimization. So I'm
Optimization.
putting in
Okay.
optimal values. This is my new
Okay.
function. So I have named it a value function or whatever you want to say, but you have to keep it. The main character of the story from here is A. The extra thing, uh, it will always be A because Tucker, you will see all the questions they are using A
It
convention.
is a. Hmm.
So you have to partially derivate it with respect to A always.
Hmm.
Put in the values of A, the limit which you got in the optimization, and see, you just need to prove that for lesser value, the differentiation is coming out as lesser. For greater value, it is coming out positive. So there is directly proportional relationship between the slope and A. So you will see that though function will decrease later, but you will get a value of A for which it will keep increasing for a certain period. And that slope you are finding using envelope theorem. Are you getting my point? Is it still about, sir?
I'm getting थोड़ा सा ma'am.
Acha, okay. I'm giving you this freedom that you revise it and
हाँ.
come back with the questions that what is that which
Tomorrow
you are not
morning,
getting.
ma'am. I'll do it
ठीक
now. Revise it now.
ठीक है. And then see, we've got
Call
that
2 hours class
questions.
if taken. Ma'am, I think if we solve 2, 3 more questions,
हाँ,
I'll do one more of the same type.
हाँ. You do this one
And then
maximization root xy and
I
also
was saying this question.
earlier question which we took, we did
The
not
circle
talk about
equation.
KKT. We did not talk about KKT here.